Okay, so we're going to talk about 8.2, and it's exactly like 8.1. This is what we talked about in 8.1, except for that. So what does that do to a graph? So we're going to find out. So we're going to talk about something called zero of a function. I talked to you guys about this briefly when we were actually doing factoring. And I told you that when we're factoring and we're solving for x equals and you get a couple of different answers, that it's those places right here where the x intercepts. So we're just going to be finding those today. And that's going to help us with our graph and how we graph. And actually make graphing kind of easy and somewhat make it like uh, programmatic or like automatic in some ways. So graph each function and find the intercepts and how do we found them. So if you actually look at this, if you have y equals x squared minus 7, if you set y equal to 0, that'll give you the x-intercepts because this is where y equals 0. So anywhere along here is the x-intercepts. So if you have this equal to 0, well, now I can just add 7 to both sides, and I get x squared equals 7. Well, anytime you're trying to undo a square, you take the square root. Anytime you're trying to undo a square, you take the square root. So x equals plus or minus the square root of 7. And here's the thing with that. If you want to approximate that so that you could put that on a graph, this is approximately 2.65. So what does that mean for my graph? Well, it means when x is 0 and y is 0, actually when x is 0, I'm sorry, when x is 0, y is equal to negative 7. So my graph starts all the way down here. But then when I'm looking for my x-intercepts, they are at 2.65, positive and negative, so they're here. And you can very quickly then draw a graph. Sorry, my U's aren't going to be perfect first time probably, but my parabolas, but it's something like that. Okay, so if you have a problem, first of all, set it equal to 0. So 0 equals negative x squared plus 1. Add the x squared to both sides so that you can get x squared equals 1. Take the square root of that. So when you do that, you get x equals plus or minus 1, because the square root of 1 is 1, and it could be positive or negative, because negative 1 times negative 1 is 1, or positive 1 times positive 1 is 1. So if you look at this, you can see we're going to be going down. Our graph is going to go downwards, and it's going to start at positive 1. The positive 1 right here. If I make this equal to 0, then y equals 1. That's my y-intercept. My x's, however, are at 1 and 1. And that might not be enough for me to figure out how to do this particular kind of graph as far as like how big or wide to make it. So you might want to throw in here the 2. So 2 times 2 is 4. Negative 4 plus 1 is, I did the 2, right? Yeah. Negative 4 plus 1 is negative 3. So you can see where the graph is going and about how wide you should make it from that point. Okay, try to make it more U-shaped up here. I didn't do that. Okay, so that is what happens with your C. This C right here, just to revisit the actual equation, this is your y-intercept. So it's where the graph hits the y-axis. Okay, let's try some more. So vertical, remember, is up and down. And so when you're looking at a vertical translation, it's going up or down, up or down. And if that C is less than 0, it's going down. And if the c is bigger than 0, it's going up. And that makes sense because these are the negative values of y and these are the positive values of y. So positive y, negative y. So that completely makes sense. And then you still have your axis of symmetry being the y-axis still. We'll get into more of that on the next lesson. So this is exactly like the one I just did above. Just to remind you, you set this equal to 0. You add the x squared. You take the square root. And you get plus or minus 1. And that's what we call the zeros of the function. If you're looking at this one, set it equal to 0. Add the 4x squared to both sides, because you want them to both be positive. You can't have a negative square root. So 4x squared equals 16. I would go ahead and just divide by that 4 real quick, get it out of the way. That way you don't have to do it later. And you have x squared equals 4. Take the square root, and you get x equals plus or minus 2. So this one, again, you want to keep things positive. So whatever's negative here, you always move it over. So x squared, you're going to add that to both sides. So x squared equals 64. Well, what is the square root of 64? Plus or minus 8. Last one. Again, move over whatever is negative here so that it can become positive. You cannot take a negative square root. Why? Because it just doesn't work that way. Those are what we call imaginary numbers. I touched on those before. I told you you'll get more into that in Algebra 2. Divide by 9. So you get x squared equals 1 over 9. When you take the square root, you're taking the square root here of the numerator and the denominator. So you get x equals plus or minus 1/3. And that is how you find the zeros of the function. So I went through that pretty quickly. If you need to stop the tape real quick and review this and take a look at it and wrap your head around what I did to find the zeros, remember this is the place in the function where it actually hits this x-axis. So we call those zeros because it's where y is 0. So before you even graph something, take a look at it and kind of give yourself a little determination on what it is you're looking to do. So if you take a look at this graph right here, the very first one, you're looking at what is it doing? Well, first of all, it's going down, right? So it's going to be going down. Secondly, that 3 right there means this is going to be a stretch. It's going to stretch the graph up, actually down in this case. And then this means this is where you started. This is your y-intercept. So it's actually going to start right here at -2. But let's plug some values in and just see what we get. So we get -2, -1, 0, 1, 2. And with that, we get -14, -5, -2. Remember, this is where y is 0, so that's going to be our intercept, -5, and -14. So you can see the values here and here are the same. So you could do a plus or minus 1 and it would give you the same result, just like we were doing in the last lesson. So when you graph this, -1, -5, and then you know it's going to go way down here. So it's going to go down really quickly. And you're good to go. So if you have any questions on that, let me know, because I know that's a little bit different. And I want to make sure you kind of get the concept of how I graph that without doing a whole lot of work, or even using a graphing calculator for that matter. So again, take a look at this before you actually graph it and decide what is happening so I know what my graph should look like in the end. So this is my y-intercept. So it's going to start my graph at -4. This means it's going to be shrinking my graph, which means it's going to be very wide. And it's also going to be positive. So it's going to go up, and it's going to look something like that. So it's going to go up because it's positive, shrink because it's a fraction, it's less than 1, and this is my y-intercept. So when you put some values in here, you can actually figure out where your things are. And you could put this in the graphing calculator too if you needed to, so that you could actually figure it out that way. But when you do that, you actually get the values for the graph. And 1, 3.5, so 1, negative 3.5, so 3.5, it's barely moved. And then negative 2, negative 2, and 2. So you can see how wide this graph is. And that's about what it should look like. Obviously, I didn't go beyond that to get the exact values, but that's about what it should look like. A wider graph going upwards and a y-intercept. Okay, 2 more. Again, before you start to graph something, please take a look at it and determine what's happening. This is my y-intercept right here. So there's my y-intercept. I know this is going to go down because it's negative, so my graph is going to look like that. But it's not going to shrink or stretch. There's no shrink or stretch here because this is part of your parent function. The only difference between this and the parent function is that it went up, started at 5, but it also is going to go down because of the negative. Otherwise, it's just like your parent function. So if you do negative 2, negative 1, 0, 1, 2, and you just throw some numbers in there, 1, 4, 5, 4, 1. You see how I can do that because it's a pattern. So throw that in there and you get 0, 5. So it's going to start all the way up here. Negative 1, 4, 1, 4, and negative 2, 1, and 2, 1. And then you get from there a pretty good idea what your graph's going to look like. Again, we're sketching graphs here. I'm not trying to be super duper 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 exact, but I want you to get an idea how these are done. So this last one, this is your parent function right here, parent function, which means it's just what we call the graph that's like the granddaddy, so to say. And everything comes off of that graph as to how we actually do it. So I know that in the parent function, it's going to go up. And I know there's no change because it is the parent function. It's not going to stretch or shrink. And I think I just did that backwards. And this is going to be my y-intercept. Okay, so I'm going to start at negative 3. Booyah. And I'm going to just fill in some values here. 1, 2, 1, negative 2, negative 3, negative 2, 1. Again, notice the pattern, right? This is symmetrical at that intercept, so symmetrical along the y-axis right here. And negative 1, negative 2, and negative 2, negative 1, or sorry, negative 2, 1, and 2, 1. So you can see your graph. Okay, that concludes this lesson. Please let me know if you have any questions or you need a different example or further explanation. I'll be happy to help. Talk to you guys later.